This demo explores a client-initiated transmission to a server. The only key difference between this code and the prior code on the server side is that we have a handler for a data event. Everything else, the error handler, the end handler, the terminate all connections, will remain the same. On the client side, we also have a data handler. The behavior of the connect handler has also been changed to send data. Beyond that, the error handler, the end handler, and the close detection are the same. So we will start on the client side this time because this is a client-initiated transmission. So the connect event is triggered when the client has connected with the server, which we'll call the connect handler. So over here, we have our socket object. And if we want to transmit data from the client to the server, all we have to do is use socket.write. And socket.write will take in two possible values. You can either give it a string type, or you can give it a buffer type if you are sending binary data. And so this will write it onto the stream. And on the server side will have a data event, which will fire each time it detects new data that it can read. We are going to handle it with a data handler. It's going to receive a chunk of data, which is a buffer. And our assumption over here is going to be that the buffer is going to be less than some size 65,536. And this just makes it easier. Otherwise, we have to combine buffers. So the first message anyways is fairly small. For later examples, we can relax this assumption. All we're doing is we are printing out what we received from the client, which is hello, we received hello. And then we are going to send the message world to the client using socket.write. And this shows that sockets are inherently bidirectional. You can both read from it and you can write from it. So you read from it by using socket.onData, and then for each piece of data that you receive, data handler will be called. And then you can write to it by using socket.write. So on the client side, the client also has a data handler. And so in this case, the data handler that's going to do is going to receive a chunk of data, and it's going to cast that chunk to a string and then just print it out. I've opened 4 terminals, one for the server and one for each client. So once the first client connects, you can see that it is sending hello, and the server receives hello, and it sends world to that specific client. We can see the Wireshark output. So we have our 3-way handshake. And then this first message is coming from our client, which has the high numbered port number 61671, sending it to port 3000. If we look at the data over here, we can see it's 5 bytes. There's our hello in hexadecimal values. The server sends back world, which is received by this line, and that just prints it out. So the client is still connected, but because we built in a resiliency, all we have to do is hit the X, and that will do a 4-way closing handshake. The other clients can also connect to get that data, respectively. And again, because we've built sort of resiliency into our server, we can do Control-C on the server, and the 4-way handshakes will be sent to each of those clients.